Hi, I'm Monty Seltz. I'm the drive-in service manager for M&D Distributors on North Shepherd. And today I want to talk to you about how important it is to replace these fuel injection connectors every time you replace an injector. It's very important. Okay, again, like I said, I'm Monty Seltz, the drive-in service manager for M&D Distributors. And every time we replace an injector in a Cummins, we always change these connectors. And I want to read you something right here that we get from, we go to Cummins for trainings. And right here it says, the high pressure connector should be replaced any time the injector is replaced. And again, that's directly from Cummins and that's from their training. But before I get into that, I want to show you basically how this operates. And remember, this is going to be the short version and very simple. And this would be better for the camera. There's a couple of things I want to show you before I get into here. How this works, and again, this is very simple. This is your inlet, and you can see where the fuel comes in from the connector, and this goes to the rail. And you're going to have, let's just say for right now, we have 20,000 pounds of fuel rail pressure. So it comes in here, and it fills up. There's even a thing you can actually see better. You can see that. Is that okay? Can you see that?
I can now.
Okay. So fuel comes in here. Remember, let's just say stick with 20,000 pounds. So this bore is filled up with 20,000 pounds of pressure. It goes into here, right in here, and it's stored right here. Okay, we're in the closed position. So right now we have 20,000 pounds right in here. It also comes up in here and fills this chamber and goes in this hole right here and fills up this chamber. So we have 20,000 pounds here, we have 20,000 pounds here, so they're equalized. So basically, simple version, this spring tension is closing this valve, holding it closed. Okay, now the computer applies current. This little ball right here that you see, everybody talks about the little sealing ball. It sits right here, and actually you can see the wear of it right there where it sits. So current lifts the ball comes up, fuel is drained out of this chamber in here. So now we have 20,000 pounds here. We do not have 20,000 pounds here. This needle, this rod here lifts up, the needle lifts, and we have injection. The computer decides, okay, that's enough, turns the current off. The ball sits right back down in there, seals that up, and now we have, goes back up to 20,000 pounds. We have 20,000 pounds. Both are equalized, and the spring shuts it. That's the basic thing. And actually, that was a short story of how this injector works. But one thing I want you to be aware of, and we're going to discuss it later, is this hole right here. You can probably see this hole, but there's also a hole inside that hole that fuel travels back and forth. So when it travels, gets pushed into that chamber. And that's what we're going to discuss about why you need to change these connectors. Because if you don't, and debris gets caught right in here, okay, let's just say, let's work that through. Okay, debris has plugged this hole. Okay, so what happens, now we have our 20,000 pounds of fuel pressure coming into here, comes up this rail, fills up through here, through this little orifice, and it's plugged. It cannot receive that fuel pressure. So now we don't have 20,000 pounds of fuel pressure to offset this, so the needle's starting to lift. And that's when you start seeing the overfueling condition, black smoke, the dreaded fuel knock. And in these conditions, pistons are not happy. You're going to get a complaint from the pistons. So you need to be aware of this. And now I'm going to show you why you should change that. And let me get to the next phase. Okay, Now here is where I'm going to show you exactly what's going on in this connector, this high pressure connector. And besides the obvious things, like this is a brand new one that they installed improperly. You probably cannot see that, but there's a mark right here. So basically that small amount of damage, and it's not much, you cannot use this anymore. But anyway, this is a connector we're talking about. And you can see there's the end, and you see those 3 openings right there? That's the sharp edge filter we're talking about. It has 3 openings, and that wears. And also I'm going to show you how it actually operates in this link, and try to prove to you that you should not reuse these and not clean them. And let me move on to that. So I'll pick this little guy up, and you can see this is what you're looking at. That's it right there. And there's where we cut it out. There it is. Okay, I get my little special tool. Fuel comes into here. If you can see that. As fuel comes into here, see there's a sharp edge right there. See where I'm touching right there? That's a sharp edge. That's what they're calling a sharp edge filter. So fuel comes in through here, flows over here, the sharp edge. Remember, the fuel pressure in a Cummins is, let's just make it simple, 5,000 pounds, probably around idle, 28, 25,000, depending on what year model. And it's pulsating in there. So think about it, fuel's coming down here. You've already run it through the 4 micron fuel filter on some models, some are 7. So the debris comes in through here, or what doesn't get caught in the fuel filter, and it flows over this. It gets pounded against that sharp edge filter, right there, that edge. And then the debris that won't pass through there, it comes right down here, and if you can see that, it stops. There's a dead end right there. So over time, debris gets packed up right in here and basically stays there. The other stuff that's broken up to some very tiny particles goes over through here, jumps to this, let me see, yeah, jumps over here, and you see that's dead in there, and goes right into the connector, through here, and into the injector. But the problem is, when you guys clean them, and let's say you put brake clean in here and you blow them backwards, and you smack it, and you Bowdooth ways, you know, whatever you want to do, let's discuss what's happening. Okay, I can barely see this. Let me see. Okay, we're back on here. This is where it stores it, right here, this dead end. And you just cleaned it, pounded it, and you got them broke loose. And let's say you didn't get it all out, or let's just say you got it all out. This baby's spotless. But what you cannot clean is the wear out of these edge filters. They wear. So cleaning them doesn't repair them. Because as over the years, what do you got, 100,000 miles? 150, 200, 300,000 miles? You own these links? The debris and fuel actually wears that link down, wears that edge down. And as that edge is worn away, now that you've got it supposedly clean, you're going to put it all back together, and now this edge filter doesn't work anymore. Because the fuel, because it's worn down right here, right on that sharp edge, that debris that used to get cut up and stacked right here flows right around it and right into the injector. So that's what I'm trying to tell you is, yes, me personally, you can't clean them, because remember that the debris is being packed in this little dead end right here at 25,000 pounds, 28,000 pounds. So I really don't think you can clean them. Now you may be able to break them loose some, but again, you're breaking loose the debris on a worn sharp edge filter here. So now the debris just hops over and goes right in the injector. And now the next thing I'm going to show you is where it goes and what happens to the injector when that debris just hops over this and goes right through here, right into the injector. Now the next thing I want to talk to you about is the leakage that these connectors can cause if you reuse them. And you have to remember, this is your only sealing point between this fresh rebuilt injector, new link, It goes right here. This is what it sits like into the engine. And you have to understand, at idle, there's about 5,000 pounds there. Remember, 25, 28,000, depending on your model. But there is no gaskets. That's it. That's just a metal-to-metal seal. So, and everybody knows what happens. And I'll just read down what I've stated before. I'm just going to read this off. But not changing these, you can cause high injector fuel return flow, because it could leak right there. So, and there's a common bore in this whole cylinder head, and so when you have leakage out of here, this connection right here, it goes in there and right out to the back of the engine, back to the tank. Black smoke, and why do you say black smoke? Low rail pressure, seems like on common rail engines, causes black smoke. And you should remember that. Remember, the 6.7s have exhaust systems on them, and those exhaust systems are expensive. So one of the things we use for diagnostics on the 6.7s Dodges, because of the exhaust system, is we monitor rail pressure constantly, and we also measure injector and the fuel supply pump flow. We don't measure pressure here in our shop on the pumps on Dodges. We always do a flow, and we can get in that later. But you know, pressure's pressure. We want flow, and that's what we do on ours. It also causes low rail fuel pressure, which we discussed. It'll cause a misfire if it's really loose. Hard start, because it can't build up rail pressure cranking, especially when it's hot, and I'm going to get to that in a minute. Low power, because it can be blowing fuel out of here instead of into the injector. It can damage the injectors. It can damage this sealing area. It can cause, and here's something I want to talk to you about. It can cause high fuel. It can cause high fuel temp. And that's really what I want to discuss. Beyond the obvious thing is people forget that this will raise the fuel temperature of the diesel in the engine. And when fuel temperature, fuel, like any fluid, when you heat it, it thins out. So, and that's why you get well, a customer will tell you, man, it starts in the morning, but when I go someplace, the truck won't start because the fuel's thinned out. So that small leak the high pressure pump could overcome when the fuel is cold, it cannot overcome when the fuel thins out and the fuel leak is multiplied itself. So I'm going to give you a little background on this particular picture we have here. Okay, this is this connector. This came out of a Snap-on truck with a rebuilt engine, and I don't want to get too far deep into that. It had 6 rebuilt M&D injectors in it. And his complaint was, Monty, it runs fine, everything's fine, except, when I'm pulling a hill or I'm trying to pass somebody on the freeway. But you also have to remember, Snap-on trucks are heavy. I mean, they're never not heavy. So we did all the basics, everything looked good, even made rail sitting here in the shop pass the test. But the customer brought it here for us to find out what's wrong with it. So we went through the complete diagnostics, and we had high return. It wasn't high return to cause an issue, let me back that up. It was still within specifications, but it was on the high end. And I want to mention something also. I use it for diagnostics because we install M&D injectors and we replace the links. I know that if it has 6 rebuilt M&D injectors in it, 6 new links, it flows 37 milliliters in 60 seconds. So I know I can pull that 160, 150, 140. By changing these injectors, I can bring that down to about 37. And I know that's going to take care of his problem. So I called the customer, and I told him we're going to pull the links, and I asked him, M&D injectors, did the shop change the connectors? And he said no. So we pop them out. And remember, I'm not a scientist, but you can, to me, if you can see that, that's high pressure leakage. Because on this particular one, his problem was at full load. Basically, let's just say that. So at the very top end of his fuel rail pressure, I believe, and you can see it right here, fuel was being blown away at such a high temp and high pressure, it was burning off the coating of this connector. So to me, that's a good visual aid right there. So the repair of this truck is all we did was put a set of links in it, and everything went back to normal. And I called the customer about 30 days later, and he said everything's fine now. So leakage is bad, but here, let's discuss this a little further. Okay, engineers, they're amazing people. When they design something, how am I going to put it? They don't design a lot of extra in it. You know, if it needs this amount, they may give you a little smidgen, but you know, the pump pumps this much fuel, this injector pumps this much fuel at this RPM. They know that. They know it down to an exact science. So let's say you reuse the injector. Reuse the fuel connector on this brand new, or this fresh rebuilt injector from M&D, and we have leakage, and you're saying, well, it's only leaking a little bit, the pump will overcome it. Okay, let's just stick with that. Let's stick with that. So now we're having fuel that the engineers designed. Remember, when you compress diesel fuel, it gets hot. This thing sits in the dead center of that cylinder head, which is hot. This goes through the cylinder head, which is hot. So that hot fuel that your engineers designed was supposed to go into the pistons. Now it doesn't. Well, it does some, but now we have a leakage, now that fuel that's been hot because it was compressed, went through the cylinder head right here, and it goes through the fuel rail through the cylinder head, we superheat it. So now we're putting that hot fuel back into the fuel tank, and I think today's tanks are plastic, so figure that out. So what we're doing, we're heating the fuel in the tank, it comes back up, we're reheating it again, we have leakage. That hot fuel that was supposed to go into here, all of it, now some of it is going back to the tank. It constantly is repeating itself, so the problem gets worse when it's hot, because all you're doing is you're superheating the fuel because you're not repairing the leak right here. Now when I say leak, it could be a very small leak, it could be so big it won't even start, or like this particular one, it pulled the power down at wide open throttle. But you cannot get around the fact is, by not changing things and getting a nice seal here, a nice seal here, is you're getting a little leakage here, from very small to very large. But the problem is, you're overheating the fuel. And that's what we don't want to do on common rail engines. Okay? Again, this is Monty at M&D Distributors. If you have any problems, we're here all the time. Just give us a buzz.